Hello everyone, this is Swati from Tata Elxsi, presenting Ethernet switch layer 2 compliance testing using Automate and Valkyrie Manager. This slides provides an overview about Tata Elxsi. Tata Elxsi is an integrated design and technology based company headquartered in Bangalore, India. We do consumer research, technology consulting, product design, development, and testing of various industry sectors like transportation, broadcast, communication, medical electronics, etc. This is enabled through a core team of 7,000 plus engineers and technologists who work from different locations in India and service our global clients. In automotive space, we work for the last 20 years and brings together a world-class embedded mechanical testing, AI analytics and IoT practice, and also an award-winning HMI team backed by the ASPICE process. With these enablers, we are driving solutions for connected autonomous electric cars of the future.
Introduction to Automotive Ethernet. As we know, automotive industries are implementing more features towards connected car and autonomous driving. This leads to higher bandwidth requirements. To meet these requirements, automotive industries are adapting Ethernet. In order to standardize the Ethernet usage across the industry, Open Alliance, a non-profit organization, was started. Open Alliance defines the compliance requirements related to physical layer, switches, and end devices. As we can see in the depicted picture, there are 7 layers and there are protocols listed against each layer. For all the layers, test cases have been defined by Open Alliance. Currently, Tata Elxsi is using Xena's Valkyrie Manager to perform Ethernet Layer 2 testing for an Ethernet switch. Data link layer. Data link layer basically covers the Ethernet MAC, virtual LAN requirements and address resolution protocol requirements. The test case categories as listed below. We are using Open Alliance Automotive Ethernet ECU Test Specification Layer 2 version 3 for the test solution development. Test system architecture. Tata Elxsi is using in-house proprietary tool Automate as a framework and Xena's Valkyrie hardware for the generation of Ethernet packets according to the compliance requirement. Automate is built on a NI platform with a keyword-driven architecture. Keywords are basically libraries developed using LabVIEW. Currently, the communication between framework and the hardware will happen through TCP/IP connection, and there are set of command set defined by Valkyrie Manager. So those commands shall be invoked with the help of libraries from Automate, and according to the requirement, Valkyrie shall generate the packets and that shall be sent to an ECU. As there is a physical layer difference between the Xena hardware and the ECU, we are using media converter to convert the RJ45 to broader reach. To explain a brief about Automate, Automate enables validation of multiple automotive systems. Automate provides an end-to-end solution right from the test case generation to the hills management, and it also enables connection to the third-party tools using ALM plugins. We can also execute the test cases remotely with the help of Test Manager. We can also develop the test cases or generate the test cases with the help of Test Editor and the tool Graffiti. We also have a dashboard tracker to view the productivity figures as well as the previous results. Automate workflow basically is explained in two different paths. One path basically covers the test case generation, another path which covers the hills framework development, hills integration and test cases throughout. Test manager shall maintain the verdict and evidences for each test session. Dashboard monitor provides the hill utilization, test execution productivity, and test case development productivity according to the requirements. Valkyrie Manager. Valkyrie Manager basically generates the different types of frames which is required for the testing of RFC 2544, RFC 2899 Open Alliance time sensitive network requirements. So Ethernet packets which is required for these shall be generated with the help of command line. Currently, Valkyrie Manager, with the help of Valkyrie Manager, we can test Ethernet switches, gateway, Ethernet end devices, security devices, etc. As a part of this demo, we are explaining one VLAN test case, which is basically the transmission of VLAN test case to the right end port according to the VLAN requirement. The test case flow shall happen like this. Initially, the TCP open, that is the connection open between the framework and the hardware will happen. Then, at what configuration my hardware should be running shall be done through this configuration file read. Then, we will write the commands, that is the Xena API's command set which we have listed here. Then, ECU's outcome is captured by the Valkyrie hardware. Verify packet or count or the verify packet header shall analyze the packets and define the results, and log file is basically maintained between the automate and the Valkyrie. What and all the command set is transmitted will be captured through log file. Now let's get into the test system demo and the test execution demo.
The test cases are loaded into the ATS from database. The file configuration settings can be edited to choose the result folder by clicking the File Config button. Select the test cases for which the test stand sequence is to be built and drag it to Build ID list. Click on Build button. Sequence is built successfully. Select the built test cases which are to be executed and drag it to execution list. Click on the Run button. The live execution status can be seen in the right side of screen. The log file for each executed test case is generated with Xena commands and responses. The report file for each executed test case is generated. Double-click on a test case to view its report in PDF format. The report of switch WLAN 001 is shown. The total execution time and the result is displayed. The status of the individual step of the test case can be seen. To verify frame received at the 03 port is untagged and TPID is correct. To verify frame received at the 05 port is untagged and TPID is correct. To verify every frame sent from the test station that is expected to be forwarded according to the customer's WLAN requirements has been received at the 03 and 05 ports. Log file for switch WLAN 001 test case. The report of switch WLAN 002 is shown. To verify frame received at the 03 port is single-tagged and inner and outer TPID is correct. To verify frame received at the 05 port is single-tagged and inner and outer TPID is correct. To verify every frame sent from the test station that is expected to be forwarded according to the customer's WLAN requirements has been received at the 03 and 05 ports. The report of switch WLAN 004 is shown. To verify every frame sent from the test station that is expected to be forwarded according to the customer's WLAN requirements has been received at the 03 and 05 port. To verify frame received at the 03 and 05 port is double-tagged and inner and outer TPID is correct. The report of switch WLAN 005 is shown. To verify the test station does not receive any of the frames sent. The report of switch WLAN 006 is shown. To verify the test station does not receive any of the frames sent. The report of switch WLAN 008 is shown. To verify frame received at the 03 port is untagged and TPID is correct. To verify ICMP reply is received only at 03 and not at 05. report of switch WLAN 015 is shown. To verify frame received at the 03 port is untagged and TPID is correct. To verify ARP reply is received only at 03 and not at 05. Select the test cases to be cleared from Run List and click on Run Clear to clear the list. Select the test cases to be cleared from Build List and click on Build Clear to clear the list. Click on Log Out to log out from the ATS.
Thank you.